Hello, sixth graders. This is Chapter 1, Lesson 7, Ratio and Rate Problems. And we are going to think about this real-world link now. An arcade sells game tokens individually or in packages. They are having a sale on token packages as shown below. And if you look at the chart, you see that one package is $5, two packages is $10, three packages is $15. So based on that, what would you say that $20 would buy you? We can see the trend here, 5, 10, 15, 20 is next. So that's one way we could figure it out. So if 20 is the next number in the right-hand column, what would be the next number in the packages column? Well, that would be 4. Can you see any other way that you might be able to figure that out? Well, we can see that 5 divided by 5 is 1, 10 divided by 5 is 2, 15 divided by 5 is 3. So what's 25 divided by 5? That's 5. 5 times 5 is 25. So how do we explain this? We could say that you divide the second column by 5 to get the number of packages. Right, the actual abbreviation is this, packages. There we go. So what's the unit price? In other words, how much to buy one? In this problem, 1 is one package, okay? So the unit price is $5 per one package. How much would it cost to buy 6 token packages? So if you divide by 5 to figure out how many packages that much money is worth, what would you do if you want 6 to figure out how much that would cost? Well, you'd multiply by 5. So that is 6 packages times $5 per package equals $30. Did you remember your dollar sign? We are talking about money, so that's appropriate to put a dollar sign. Number 4, the arcade sells individual tokens for 25 cents each. Individual. If a token package contains 25 tokens, that's important information. A token package contains 25 tokens. How much would you save? This is interesting. How much would you save is the actual question by buying a package of 25 tokens instead of 25 individual tokens. So we need to know how much it would actually cost to buy 25 individual tokens before we can do the math to find the actual answer to this problem. So we know that we were buying 25 tokens, and we know that the tokens cost 25 cents each individually. So we are going to first multiply the ones place by everything in our top number. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Now we'll multiply the tens place. We want to put a 0 down because it's the tens place. 2 times 5 is 10. 2 times 2 plus 1, that's 4 plus 1, 5. Now we add. 5 and 0 is 5. 2 and 0 is 2. 1 and 5 is 6. Where does the decimal go? Here, the only decimal has 2 digits to the right of it. So in our answer, we need to have 2 digits to the right of it. Oh, and we are dealing with money, so that makes sense that there would only be 2 digits to the right. Decimals are here, assumed here when you cannot see them because this is a whole number. We're going to move it 2 places, 1, 2. So It's going to cost $6.25 if we buy each token individually. But if we buy a package, $6.25. If we buy a package, let's look up here again. One package is $5 right here. One package is $5. So how are we going to figure out how much we save? Because that's the actual question. Yes, we are going to subtract. We're going to subtract $5, which is the package price, from $6.25, which is the buying it individually price. 5 take away 0 is 5. 2 take away 0 is 2. 6 take away 5 is 1. And our savings would be $1.25. Remembering our dollar sign because this is money. $1.25 savings. Oh, I'm buying the package, that's for sure. Let's move on. Another way to potentially solve a problem is to create a bar or tape diagram. And over here, I want you to point this out right here. This is great information that you will need in this lesson. It says, notice that the numerators of both fractions in methods 2 refer to the number of students who like gel toothpaste. The denominators of both fractions refer to the total number of students being referenced. So we call that a ratio that compares, let's switch here, compares the part to the total or the whole, part to whole, okay? Sometimes you might compare part to part. So pay attention to that. What is the problem asking you for? Are you comparing a part to the total number, or are you comparing a part to a part? Heritage Middle School has 150 students. That's the total, right? 2 out of 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. Notice that they set up a tape diagram with 3 parts, 1, 2, 3. Okay, and they labeled here that there are 150 students. We know that 2 out of the 3 preferred gel, so they sectioned off 2 parts as gel prefers, and the final third one does not prefer gel. So if we want to know about how many students are going to say they prefer gel, we could then just section off the 150 students, which they chose a tape diagram because it's pretty simple to see that that's 50, 100, 150, right? So 2 parts of 50 students, that would be 100 students that prefer gel toothpaste. Number 2, the ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister. Lucas compared to his sister is 3 to 4. So that's a part, right? Part to part. Lucas sent 18 messages. We want to know how many his sister sent. All right, so here's the tape diagram. And we see 3 parts, 1, 2, 3 for Lucas and 4 parts for his sister. And we see that Lucas sent 18 texts, while 18 divided by 3 is 6. And that's how they derived that they should put a 6 in each of the 3 parts, and in fact, all the parts. Well, now we know that if every part is worth 6, and sister sent 4 parts to 3, then we should do 6 times 4, which is 24. His sister sent 24 text messages. Okay, here is the same problem set up as equivalent fractions, and we can see that 3 times 6 is 18. Whatever we do to the numerator, we should also do to the denominator. Bigger numbers, so I'm excited now. In a survey, 4 out of 5 people preferred creamy peanut butter. There are 120 people shopping at the grocery store. Use the survey to predict how many people in the store would prefer creamy peanut butter. Well, we could set that up as a tape diagram. That wouldn't be so difficult. Okay, so if our tape diagram looks like this, and this is 4 out of 5, so we need 5 sections. 1, 2, 3, 4, 5. I'm going to shade the 4. Oh, that's not a highlighter. Try again, Miss Munyon. Here we go. 4 out of 5 prefer creamy. These are the creamy prefer people. Creamy. How many are there in all? In all, there were 120 in the store that day. 120. So how many of those are going to prefer creamy? Well, we need to know how much one part is worth, and there are 5 parts. So let's do that math really quick. 5 into 120. 5 goes into 12 2 times. 2 times 5 is 10. Subtract 12. Take away 10 is 2. Bring down the 0. 5 into 20 is 4. Each part is worth 24. 24. And 4 parts were people who prefer creamy peanut butter. So what should we do now? Well, I think we need to take how much is 1 part worth and multiply it by 4. Okay, 4 times 4 is 16. 4 times 2 is 8, plus 1 is 9. 96 people on that particular day will likely prefer creamy peanut butter. Let's try the next one. A survey found 12 out of 15 people in the United States prefer eating at a restaurant over cooking at home. If 400 people selected eating at a restaurant on the survey, how many people took the survey? Well, the first thing I notice is that we have a part to whole or part to total question here. We know 12 out of 15 people prefer eating at a restaurant. So if 15 people take the survey, 12 will prefer eating at a restaurant. And 15 is the whole. So what is this? Is 400 the whole or the part? If 400 people selected eating at a restaurant on a survey, it's a part. So 400 prefer that. How many people took the survey? How many people took the survey? So we need to know how many people took the survey. We know that 400 prefer eating at a restaurant on this particular one, and that should represent 12 out of 15. But look at this. I'm not confident that 400 divides evenly by 12. Well, 12 times 10 is 120. So 12 times 20 would be 240. Yeah, I'm not particularly, and I know 15 doesn't go into 400, but that's just me saying it. So let me show you really quick. So 15, we need to do 12. 12 into 400, so 3, 36, 40. 12 does not go into 40 evenly, so how do we solve this problem? Any ideas? I'm going to erase this. Do you remember in the last section when we scaled back and then scaled forward? I think that's what we need to do here. So if we take a ratio 12 to 15 and we divide by 3 over 3, then our new ratio would be 4/5. 12 divided by 3 is 4, 15 divided by 3 is 5, and 4/5, we know 4 goes into 400. Now we've got a pretty simple equivalent fraction to figure out. 4 times what equals 400? 4 times 100. That means we need to multiply 5 times 100, and that would be 500. So how many people took the survey? 500. Let's take a look at the next one. The Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? So they drove 105 miles, 2 gallons of gas on 4 gallons. So how far can they go on 6 gallons? Well, here they set up, see, gallons, 1, 2, 3, 4, 5, 6, and miles, sorry about that, on 1 gallon of gas. Having a little problem here. Here we go. On 1 gallon of gas, they drove how far? Oh, how far did they go on 1 gallon of gas? Well, they did the math up here for us. 105 divided by 4 is 26.25. Yes, my dearies, sometimes we're going to have a decimal. So that means if we multiply 26.25 times the number of gallons we actually are going to use, we get 157.5 miles on 6 gallons. Cool. Ooh, look at this one. 810 calories in 3 scoops of vanilla ice cream. Oh man, that's almost my calories for the day. How many calories are in 7 scoops? How many calories in 7 scoops? Well, first we have calories, 2 scoops, and initially we had 810 calories in 3 scoops. We want to know how many calories in 7 scoops. I can't think of a way to do, I can't think of a way to multiply a whole number times 3 and get 7, but I am noticing, do you remember this trick? If you add up the digits in a number, so that'd be 8 plus 1 plus 0, which equals 9, and if the sum is divisible by 3, then the number is. So that means 810 is divisible by 3. Let's try it. 3 into 810. 3 goes into 8 twice. That's 6. Subtract. 8 minus 6 is 2. Bring down the 1. 3 goes into 21 7 times. That's 21. Subtract 0. Bring down the 0. 3 goes into 0 0 times. Oh, so 810 divided by 3 is 270. Is that useful information? Yes, because what do I know now? I need to make this a little bit smaller. Here we go. I now know the unit price. So the unit price is 1 scoop of ice cream has 270 calories in it. Can I now figure out how many calories in 7 scoops? I can, because I know that 1 times 7 is 7. I only need to multiply the numerator by 7 to figure out the calories. So let's do that. 270 times 7. I'm going to change colors here. 7 times 0 is 0. 7 times 7 is 49. 7 times 2 is 14 plus 4. That's 18. Wow, that's a lot of calories, guys. Let's make that sharing size, okay? 1,890 calories in 7 scoops of ice cream. Whew. All right. Jeremy drove his motorcycle 120 miles in 3 hours. At this rate, how many miles can he drive in 5 hours? At what rate did he drive his motorcycle? So they set it up, 120 miles to 3 hours. They divided both by 3 to get the unit rate. Okay? What was the unit rate? 120 divided by 3. 3 goes into 12 4 times, so that's 40 miles. Okay? And then they set up 120 miles to 3 hours equals, oh, there it is right there. I thought they had it there. So the unit rate is 40 miles in an hour. And if we multiply that by 5, we find that Jeremy can travel 200 miles in 5 hours. Let's take a look at this last one, D. While resting, a human takes in about 5 liters of air in 30 seconds. 5 liters of air in 30 seconds. Air to seconds. At this rate, how many liters of air does he take in 150 seconds? How many liters? So we need to know 30 into 50. Well, if we set this up like this, 150 divided by 30. First, we see we can cancel out the zeros. So really, this is just 15 divided by 3, which is 5. So 30 times 5 equals 150. All right, so what's 5 times 5? That would be 25. So what was the question? How many liters of air does he take in 150 seconds? Well, that would be 25 liters of air. 25 liters of air. All right, guys, your turn. Let me know if you have any questions.